In this video, I'm going to go through the civil structures question 9b from the page 69 of the Copeland book. So in this question, the loading situation looks like this. We have 5 forces on our truss. We have 3 active applied loads, right? The 900 newtons, which is at 30 degrees. We have 400 newtons, 500 newtons mid-span, and we have 2 reactions. We know that reaction Y has to be perpendicular. We're making the assumption that it's going to be perpendicular straight up, and we know that reaction X is going to have some horizontal component because it's the pin, and we have a horizontal component here. Now we can, because there's only one horizontal force pushing to the right, the reaction has to be pushing to the left in order to balance that. So that's where I've drawn this sort of as a wavy line, because I'm not exactly sure what angle it's going to be, but I have a rough idea. I have an assumption of where things are going to be. Now, the first thing we typically do is we find we find the reaction at the pin. In this case, we find the reaction Ry. But to do that, we need to take moments from the opposite point. Effectively, we've got a horizontal and vertical unknown here, which is too much for us to deal with. So to eliminate that, we multiply it by 0. Multiplying it by 0 means the answer is 0. We can then continue with our equation. So to make that number 0, we take moments measured from point X. We could take moments from any point on this truss, and it would be okay. But if we take moments from point X, we can eliminate the forces at X. We've set a convention. We're going to say that clockwise is positive. My practice is to always set clockwise as positive. At uni, about half my lecturers used anti-clockwise as positive. HSE answers tend to be about half and half. So we're saying the sum, this is the sigma, means the sum or the total moments at any point happen to be 0. We're saying the total points measured from point X is 0, and we're going to use the convention of clockwise as positive. Okay, so we've listed here 1, 2, 3, 4, 5 forces. I've said Rx is already, we're going to treat that as 0 because it multiplies by 0. I've also said before in the previous recording that Copeland will probably not include that number in his calculations. He'll just ignore that. So let's have a quick look. If we look here, Copeland has completely ignored that force. So he starts at the 500 kilonewton force, the 400, the 900 force, the 900 force in the opposite direction, and the reaction Y. Now I'm going to go back to my photo. You'll notice that we only have one force at 900. We only have one force at 900, and that's because, unlike Copeland, we are taking our forces, we're just going to measure our force perpendicular from our point X. So what we're going to do is we're going to follow along the line and find the closest point, which will be our perpendicular distance, and we're going to calculate that distance, and then we're going to save ourselves having to split up the forces. Now, there's a good reason why no one does this. The reason no one does this is you need to break up the forces into the horizontal and vertical components later anyway, so you might as well just do it to start off with. But in this case, it happens to be an easy one, and I think it's a good example of an alternate method, and it was the method taught in the or asked about in the 2018 HSC. So, if we go through our 5 forces, first of all we have Rx. We're multiplying it by a distance of 0. We've ignored it. The next force is 900 newtons. Now, if we look here, we've said it's 30 newtons from the point of the truss, and we know that this angle here is 60 using alternate angles on parallel lines are equal. Using that proof, we can say that this angle here is acting 90 degrees from this point. Are you all okay with that? Now, because in this case, we've just been told that they're equilateral triangles, we have just had to assume a length, and that's fine. We've said before, it doesn't matter if you use newtons or kilonewtons, it doesn't matter if you use meters or millimeters, it doesn't matter if you use pounds or feet, right? Because as long as you're consistent, your answer will come out consistently. So, in this case, we've said that a length of a triangle in each side is 1 meter. We've said each side of the triangle is 1 meter. So the distance, the perpendicular distance to this force is 1 length of the triangle. Because that is already at 90 degrees and it's touching, so 90 degrees happens to be one side of the triangle. Now, if that doesn't make sense, I might have to speak to you in person, let me know. But the whole idea is here, if we imagine this force passing through, the point where that force is going to be closest to X is here. that's where it's closest to x. If we keep going, that's where it's, boom, that's where it's closest to x. If we measure that distance, the radius where it's closest to x, it's one side of the triangle, 1 meter. So in this case, it's easy just to say 1 meter. But we're going to look at how that works when we look at Copeland's answer in a second. The next one is 500. Now here it's quite obvious. Here it's quite obvious. It's 1 meter away and it's a perpendicular force. The force is being applied perpendicular to that beam, and that beam is 1 meter long, one side of the triangle. Now, some people had questions about how we found the 400 newtons. The 400 newtons is one triangle and half a triangle away. We don't ignore this top triangle. We're just looking at the bottom. One triangle, half a triangle. So one triangle plus half a triangle is 1.5 meters. Are we all okay with that's how we've got this perpendicular distance? Okay, finally we have reaction y, which is 2 triangles away. So it's times 2 meters. Now, we've assumed that it is going up, and therefore if it's going up, it is going to be anti-clockwise, so I've used a negative sign. I have said I always write the negative sign because you can turn a negative sign into a plus, you can't do the other way around. Okay, so what we effectively end up getting is 2ry equals 2,000. So if two red yo-yos cost $2,000, how much does one red yo-yo cost? 1,000. The answer was positive. So if the answer is positive, that means our assumption was okay. Positive, therefore our assumption was okay. Therefore it's going up. Ry is 1,000 kilonewtons going up. Now, that's one way of looking at this question. It's not the way that we would typically do it. If we go to the Copeland answers, we can see the way Copeland would do it. Okay, first of all, he just completely ignores Rx. That's fine. It saves you some ink. Right, the next force, he's gone 500. He said that's one triangle away. Good. The next force he's got is 900. Now, he's broken this 900 force. See how he's removed the 900, and he's broken the 900 into 2 components. 900 sine 30 and 900 cos 30. Now, we happen to know that 900 sine 30, or anything sine 30, is half. So 900 sine 30 is going to be 450, right? So what we could write here is 450, and what's the horizontal distance? What's the perpendicular distance? If we continue this line all the way down, the closest it's ever going to be is half a triangle. Yeah, if we continue this line all the way down, it's going to be half a triangle. So if we write 450 times 0.5, now the next one is a bit interesting, right? So this, first of all, we need to know the perpendicular distance. So if we extend this line across, what's the closest point? Well, the closest point is here. Now, what is the distance from here to there? What is the distance from here to there? Well, it's not half a triangle. No, it's 0.86 of a triangle, 86% of a triangle. What I call the disco number, because I have a friend called Disco and he's born in 1986. I happen to know that when we're talking about 30 and 60 degree triangles, that the opposite side, the side opposite the 60 degrees, so the sine of that triangle, right, knowing that the hypotenuse is 100%, it's going to this side will be 86% of the hypotenuse, or hypotenuse sine 60. Yeah? So, if we look at that distance, he said here, h is equal to 1, or the hypotenuse, times sine 60, right? Which he said that we know as it's a absolute value. We can say root 3 over 2, which is fine, and he's used that distance there, h equal to root 3 over 2. But just as long as we understand that concept. So what we're going to get is we're going to get 900 times 0.86 times 1 times 0.86. Now, if that helps you, all good. If it doesn't, it doesn't, right? But if you don't understand that working out, you need to come and let me know. The next thing is that the last force he has is the reaction y. Reaction y is 2 away, so he's just said 2y. Now, I don't like that he says 2y because it looks inconsistent. I like it when it's force times distance every time, but it does work, and that's how algebra works. Okay, so what he says is that ry equals 2,000 divided by 2. We get the same answer. Now, the next step, what he's going to do is he's going to say the sum of the forces vertically. So he says, well, how many vertical forces have I got? Well, I've got this 1,000, right, which is ry. 1,000 going up, so that's positive. Minus 450, which is this value here. Remember how I said that 900 sine 30 is 450. So if you didn't understand where that 450 came from, it came from this vertical force here. 900 times sine 30 minus 40, because again it's going down, minus 500 plus RxV. So RxV is the vertical component of Rx. Are we all good with that? When we rewrite that question, what we're going to end up getting is we're going to get, so we're going to have, move this over to become a minus. We're going to get minus RxV equals minus 300. The two minuses cancel. So what that means is we have a positive number, which means our assumption was correct. We assumed that RxV was going up, and it did. It was. It was great. Right? 350. Now, for the horizontal forces, it's easier. Right? I've said it's 900 times 86. Now, I can't do that in my head, but I know that it has to be less than 900 and more than 450. Right? Probably closer to the 900 size. So I'm going to say it's about 800 or maybe like the high 700s, right? 770, 780, something like that. Now, what we find is that when we look at the answer here, there's only two horizontal forces. Let's say it's the answer happens to be 779, right? 779 pushing to the right. Well, there's only one thing that can push to the left, and that's RxH. It's the only part of this diagram that's pushing to the left. It's the only thing that can maintain the equilibrium. So if he's pushing, if this force here is 779, that's going to have to be 779 back in the other direction. Once we have that answer, we're then going to use Pythagoras Theorem, right? So that now, unfortunately, you can see that he's swapped. He swapped from Rx to Ra. He did that in the other question as well, unfortunately. But look, we're going to take what we can get. It's better than wrong answers that were printed in the book. And, everyone makes mistakes. That's why pencils have erasers. Ra becomes Rx. So what we've got here is we've got the two components, 350, 779. We square those numbers, and we take the square root of the sum. What we're going to get is 854. And then we have to find the angle. Now, I don't like the way that he does the working out here. I'd rather he says tan to the inverse of tan equals, or brackets, the opposite over adjacent. So in this case, the opposite is 350 over 779 equals, if you're using the internet or if you're using Excel, you want to use the function atan, right? I'm going to pause. So I'm actually demonstrating how to get that answer in Excel. So if all you have as a calculator is Excel, what you can do is you can type in atan equals the side that's opposite, which is 350, and then the side which is adjacent, which is 779.42. And what that answer will give you is 42 degrees. Does that sound right? No, because 42 degrees, this is where, using your logic, 42 degrees means that it's roughly equal sides. Yeah, if something's 45 degrees, that means it's an isosceles triangle, right? Yeah, 45 degrees, it has to be an isosceles triangle. It's not an isosceles triangle, right? So what's wrong? Well, it's in radians. So how do we convert from radians? Well, we have to multiply it by 180 and we have to divide by pi. Now, to divide by pi, you could just type in 3.14, or you can type in the Excel formula pi and then two brackets, right? If that works for you, or two parentheses to use the coding terms. So I just want to point out that Copeland here, he has shown the wrong formula. He said 350 over 854. It should actually say 350 over 779. But he has given the right answer, which is 24.2 degrees. Now, you can give your answers in minutes and seconds. I don't. Right? So if your calculator happens to give the answer in minutes and seconds, you can do that. But typically, I will always give the answer in 1 decimal place of a degree. Okay, so that's that question. And next, I'll go and show people how to use AutoCAD.